Welcome to qnawire.
Okay, we know that the standard free energy change, delta G naught, is 0 for a reaction. We need to figure out which of the following statements about the reaction are true. The first is that the entropy, the standard entropy, equals 0. Is this true? Well, there's really no way of knowing. Recall that delta G naught equals delta H naught minus T delta S naught, where delta H is the enthalpy. Just because this is 0 doesn't mean the delta S is 0. If delta H and delta S happen to cancel each other out, then it could still be 0, right? So there's no way of knowing if delta S is true. Therefore, this statement A is false. Okay, the enthalpy of the reaction is 0. That's question B, or statement B. And for the same reason, it's possible that the enthalpy and the entropy are 0, but it's also possible that they just happen to cancel each other out, right? In which case, there's no way of emphatically stating that the enthalpy has to be 0. So B is also false. Okay. C, the equilibrium constant for the reaction is 1. Well, we need to know what the relationship between the equilibrium constant and delta G is, right? So recall that delta G naught equals negative RT times the natural log of K, where K is the equilibrium constant. And this can also be expressed through a little bit of algebra as K is equal to E raised to negative delta G naught over RT. Okay, well, if delta G naught is 0, then K is equal to E to the 0, negative 0, doesn't really matter, over RT. And here it really doesn't matter what R or T equal, because 0 over anything is still 0, so we're just going to get E to the 0, and anything raised to the 0 is 1. So C is true. And this is the relationship we need to prove it. D, the reaction is at equilibrium. Okay, well, what determines if a reaction is at equilibrium is whether the reaction quotient Q is equal to K. Then we know the reaction is at equilibrium. But Q can't tell us, delta G naught doesn't tell us anything about Q, right? So we have no information about Q just because we know delta G naught. We could know K, but Q depends on the reaction in its current state, right? K tells us the concentration of products over reactants at equilibrium. Q tells us that same information at present time. So delta G tells us nothing about Q. Therefore, D is false. Okay, finally we have E. The concentrations of the reactants and products are all 1 molar at equilibrium. This is also not true, right? So we know that K equals 1. We kind of proved that earlier. So you might be tempted to think that because K equals the concentration of the products and the reactants, that this could be 1 and this could also be 1. But that's not necessarily true. We could have that the concentration is 2 molar of the product and 2 molar of the reactants. There could be many species, and we have a 3 squared here and, a 3 there and another 3, and all of a sudden, yes, overall K equals 1, which we know to be true, but it's not because the concentration of all of our products and reactants is 1. It's, clearly they're not. 2, 2, 3, 3, 3. That would also be a perfectly valid way of having a equilibrium constant equal to 0. Of 1. So of all of these, only C is true. which I'm sure is one of these options. C only. Yeah. So E is the answer for C only.